Hi there, this is Saxon Math, Algebra 2, Lesson 48. Here we're talking about radical equations. So we use the square root property. So we had a problem like this. To solve it, we took the square root of both sides and we said x plus 2 equals plus or minus the square root of 5, and then we would solve it and we get x equal negative 2 plus or minus the square root of 5, which gave us two solutions. Now, we have to understand when we use another process to solve equations that contain a square, when we do this backwards. So instead of having a square and we take the square root, if we have a square root and we square it, we can do that. However, we have to be careful. So we know if x is a positive real number, then we set the square root of x is a unique positive real number. So we can say that the square root of x squared equals x, right? Because by definition, that means square root of x times square root of x, which means the square root of x squared, right? And we get the square root is just x. That's how we got it equals to x, right? We didn't say plus or minus. This is where we have to be careful. So we always have to check our answers because when we square them, we can sometimes generate a solution that's a false solution, all right? And we call those, they don't name them in this book here, but they're called extraneous, the word extraneous solutions. So we have to be careful when we're solving and we have a radical and we square both sides to get rid of it. So let's just dive into the problem and you'll see what I mean. So, because remember, x equals 2 is just x equals 2. Now watch if I square both sides. And then I solve this, and I take this to square it. Do I get plus or minus 2? But that's my first answer was just x equals 2. So let's look at a problem. So if I say, let's solve this radical, x minus 4 minus 2 equals 6. The first thing we want to do is we want to isolate the radical, okay? And you see it's not isolated. So I'm going to add 2 to both sides of the equation. So it's still an equation, still using the addition property of equations. And it might help if you put your radicand under parentheses so you know what is part of the radical and what's not. You see this minus 2 isn't. So I get equals 8. So I need to solve. To do this, I'm going to square this, right? Because if I square it, then I have the square root of x minus 4 times the square root of x minus 4. But what I do to the one side, I must do to the second side. So I get 16, right? So by definition of radicals, I've got x minus 4 times x minus 4 equals 16. Now I can solve this. I can take the square root of both sides. Oh no, I'm sorry. I don't need to take the square root. Sorry, ignore that. Because I have two factors, so this just becomes x minus 4 equals 16. I get x equal sorry, and I'm doing bad math here. X equal 68. Still doing bad math. I get x equals 68. Well, let's check this to see in our original problem. So if I take the square root of 68 minus 4 minus 2, does it equal 6? So this is 64. So 8 minus 2 equals 6. And I get 6 equals 6. I checked it. My solution was good. I'm good. So my answer is x equals 68. Let's try another one. So we're going to solve square root of x plus 4. So this is my radicand. Plus 2 equal negative 7. So I'm going to minus 2 from both sides. So I get the square root of x plus 4 equals negative 9. Now I'm going to square both sides because I need to get rid of this radical. Excuse me. Just like if I had the square root of 2 to get rid of the radical, I would square it, and I would get the square root of 4, which is simply 2. Right? So then I get x plus 4 equals, remember this whole thing is squared, so that becomes 81. I minus 4, so x equals 77. So let's check to make sure it's not extraneous. So I'm going to put it back into the original. This is the square root of 77 plus 4 plus 2 equal negative 7. So this becomes the square root of 81, which is 9 plus 2 equal negative 7. I get this 11 equal negative 7. No, it doesn't, so therefore there is no solution to this equation. All right, so nothing will work. All right, let's do the last two. So square root of x minus 3 equal 5. So the first thing we want to do, we isolate the radical. So the square root of x minus 3 equal 8. I square both sides. So I get x minus 3 equals 64. X equals 67. I need to check it. The square root of 67 minus 3 equal 5. That's 64. It's 8 minus 3 equal 5. 5 does equal 5. And that's my answer. Okay, one more. So I have the square root of x squared plus 2x plus 13 minus 3 equal x. You still don't panic because you have an x over here and you got a square. You're still going to isolate the absolute value. Can we factor this? No. So we're going to leave it as x squared plus 2x plus 13 equals x plus 3 because I added 3 to both sides. Okay. So now I'm going to square both sides. So we're squaring both sides. Hence, look at my parentheses. So that means this is equal to x squared plus 2x plus 13. This means you're going to FOIL this. Remember, this simplifies. This is the same thing by definition as x plus 3 times x plus 3, which gives x squared plus 6x plus, don't forget how to FOIL. I didn't do the FOIL, I just did it all in my head. So now we're going to subtract x squared from both sides, right? And then we're going to minus 2x from both sides. So we get 13 equals 4x plus 9. I'm going to minus 9, 4 equals 4x. And I get x equal 1. So let's check it. Does the square root of 1 plus 2 plus 13 minus 3 equal 1? So that's 3, that's 17. Oh wait, 1 plus 2, 16. So the square root of 16 minus 3 equal 1. No, so that means it's extraneous and there is no solution. All right, so because it doesn't work, oh, I'm sorry, that's 4 minus 3, which is 1. So it does work, because 1 does equal 1. I forget, square root of 16 is 4, minus 3 is 1, and that's my solution, x equal 1. All right, stop this and do the practice problems and then the problem sets.